Now let's look at the following about some special quadrilaterals. Remember, a quadrilateral is a polygon with 4 sides. A parallelogram is a special quadrilateral with opposite sides parallel and equal in length. Then a rectangle is a special parallelogram that has 4 right angles. So remember, a rectangle is a special parallelogram. Next, a square is actually a special rectangle that has all 4 sides equal in length. A rhombus is a special parallelogram that has all 4 sides equal in length. Now, because a rhombus, by the way, is a special parallelogram, remember, opposite sides are still parallel. It's just for a rhombus, they're all the same length. And then a trapezoid is a quadrilateral with exactly 1 pair of opposite sides parallel. So let's answer a few questions. Here we just want to basically complete this statement. A quadrilateral, that's a polygon with 4 sides, with opposite sides parallel is a or an. Opposite sides are parallel, it is a parallelogram. So there we go. True or false? Let's complete this. A rectangle is also a parallelogram. Is a rectangle also a parallelogram? Well, what makes a parallelogram a parallelogram? If opposite sides are parallel. And remember, a rectangle is a special type of parallelogram. So this is a true statement. In a rectangle, opposite sides are parallel, and also it's true that a rectangle is a special type of parallelogram. So this statement is true. But you'll want to take a moment and certainly review all those special quadrilaterals. Now let's look at a circle. Circles are also plane figures. A circle is a plane figure that consists of all points that are the same fixed distance from some point C. And then we call the point C the center of the circle. The radius is the distance from the center of the circle to any point on the circle, just as shown. And the diameter is the distance across the circle passing through the center. By the way, notice the diameter is twice the radius, and the radius is half the diameter. So here is another example of a plane figure, and that being a circle. An example of a circle, we are given that the radius of this circle is 7 meters, and we want to find the diameter. So we just want to make sure you realize that the diameter is twice the radius, or the radius is half the diameter. So the diameter here of this particular circle is twice the radius, so twice the radius, and so the diameter is 2 times the radius is 7 meters. The diameter then is 14 meters. Very important for you to be able to go from diameter to radius, radius to diameter, especially when using area and circumference formulas, which will be talked about at a later time. Now that we've talked about plane